Hey guys, go ahead and get your note sheet back out for 2-4, equations with variable on both sides. We will take a look at the back side of that right now. So we're going to look at two different kinds of special cases that might happen when you're solving equations with a variable on both sides. Okay, so this is special case number 1, and if we were to solve this following our rules for equations, there's no distributive, there's no like terms, we do have a variable on both sides, so we're going to go ahead and move the variable to the other side, which means we would subtract 2x from both sides and simplify, and what's going to end up happening in this kind of problem is the 2x's on each side end up canceling, and you're left with something like just 5 equals -3. No more variables in the problem. So anytime this kind of thing happens, when the variables cancel, it will be one of your special cases, and it depends on the two numbers left over. So because you have 5 equals -3, and if you think about 5 equaling -3, it is never ever true, so we would actually answer this one as no solutions. So anytime variables cancel and you're left with two numbers that do not equal each other, we would say no solutions. Something that can help you kind of point this out from the beginning is if you notice the original equation, you had a 2x plus 5 and a 2x minus 3. So because you have the same exact coefficient on both sides, but different constants, you basically are saying they can never equal each other. If I multiply the same number by something and add 5 and multiply the same number and subtract 3, they're just never equal. So that's why this would always be a no solution. So what we can conclude about no solution problems is when the coefficient is exactly the same on both sides of the equation, and then at the same time those constants are going to be different, then your answer would always be a no solution. And again, that's because those coefficients cancel since they're the same, and then the constants are different, which is meaning you are never equal, so no solution. Okay, so let's take a look at special case number 2. So again, we go through our steps. We're going to go ahead and distribute first. So 3 times x and 3 times 1 makes 3x plus 3. Then we're going to go ahead and combine our like terms. Remember, they have to be on the same side, so that's just the left side where we can put together our 3 and our minus 5. So when we combine, we end up getting 3x minus 2 equals 3x minus 2. And then we've got the variable on both sides, which we're going to have to get rid of. So we're going to subtract 3x from both sides, and that's going to end up leaving us with just -2 equals -2 since those 3x cancel out. So now if you kind of look at how this is different than the last one, you are left with something that is true. -2 is -2, so when we see this happening where you get two of the same number on both sides when the variable goes away, then we would call this infinite solutions or identity. And the symbol, if you're a lazy math person, could just be to draw the infinity sign and just say infinite many. And that just means any number works, because what you're saying is this equation was already balanced on both sides, so no matter what x is, it's always going to remain balanced. And if you kind of take a look at in line 3 of this equation, so that's right here, you should be able to see at that point it's exactly the same on both sides, like reflexive property, and that just means it's exactly the same, so no matter what x is, it's always going to be the same. So what we can conclude from these is that when the coefficient is the same on both sides of the equation and the constants are also the same, then we're going to always have an infinite many solutions. Go ahead and see if you can pick which one this would be from your options for your solution, and press play when you're ready to check. So this equation answer should have been infinite many solutions, and if we look carefully at the equation that we started with, we have a 12x and a 12x, and then we have a -3 and a -3. So since it's exactly the same coefficient, same constant, it's definitely infinite many. Go ahead and identify what kind of special case each of these are, and whenever you're ready to check, you can go ahead and press play. So number 1 should have been infinite many, and again, it's because I have the same coefficient and same numbers. I know it's a little out of order, but that's a +7. This is also a positive, and then the 12x's are both negatives. The second one should have been no solution, and that is because you see the exact same, and I'm sorry about that extra 2 there, but you have the same coefficient with different constants, so these are not equal, which means they're never equal. Your third one you would need to distribute first, so you're going to get a -3x plus 12, which means if you study the left-hand side of this versus the right-hand side, it's no solution. Since 12 and 7 aren't equal, it's not going to work out. And then your last one, you're going to want to distribute your -2. Then you'll want to combine your like terms. And once you combine your like terms, if you look at your coefficients and constants on both sides, they're exactly the same. Positive 2x, -2, -2. So we have infinite many solutions. So hopefully that made sense. These are just special kinds of situations that might happen. It only happens with a variable on both sides. And so when you see this mixed in with other problems, be ready to answer those. And that's it.